Welcome to this course, Introduction to Cybersecurity Literacy. This is Lesson 13, How Email Works. In this lesson, we're going to examine two illustrations that help us to understand how computers send, store, and receive emails. Some of you may be watching these videos for a course that uses this textbook. The illustrations that we're going to look at in this video are both from Chapter 4. Now, if you aren't using this textbook, don't worry about it. Just follow along with the video. To begin, let's examine an illustration that summarizes the basic parts of an email system. For now, let's pretend that an email message is moving from left to right. The sender is the user on the left, and the recipient is the user on the right. To help us to talk about these users, let's give them names. I'll call the user on the left Jack, and the one on the right Jill. Jack will begin by writing and addressing the email using what is called a user agent. In Jack's case, his user agent is an email application that lives on his own computer. Examples of such applications include Microsoft Outlook or Mozilla's open source Thunderbird email application. These applications are compatible with private email systems, like the one that Jack uses. What exactly is a private email system? Well, most people don't use private email systems for their personal emails anymore, so you may not be familiar with private email systems. Most of us are probably more familiar with web-based user agents attached to web-based email services. Examples of web-based user agents include Gmail, Hotmail, and Yahoo Mail. However, some people prefer private email services that can only be accessed from private user agent applications. Many businesses and workplaces will use private systems like these. For private email systems, users must have an email application like Outlook or Thunderbird installed on their computer in order to access their private emails. A private email system also means that Jack's emails are stored on Jack's private network. In fact, he may just store them right on his computer. If we look over to the right side of the illustration, we see that Jill has a web-based user agent. A web-based user agent stores Jill's emails out on the web somewhere. It also means that Jill can send and receive emails from any computer with an internet connection. Jack can only send and receive emails from within his private network, which contains a very limited number of computers. In fact, if it's a home network, Jack may only have one computer connected to it. So Jack writes an email, and then he sends it off through the internet. Jack's email must travel from his private email system through a series of servers called Message Transfer Agents, or MTAs, before it can reach its destination, over on Jill at the right side of the page. Jack composes his message in his user agent, and then when he hits send, the user agent sends the email to the first message transfer agent. That message transfer agent sends the email to another message transfer agent, which sends it through the internet to a third message transfer agent. The final message transfer agent would store the message until Jill's web-based user agent requested access to new incoming emails. This user agent accesses the email for Jill. But since the user agent is web-based, the information has to travel through a completely different internet path between the user agent and Jill's computer. If Jill wanted to send a message back to Jack, the whole process would be reversed. Jill would write a message in her user agent, which appears in her web browser. When she hits send, the email would travel through the internet to her web-based email client. This email client would forward the email to a message transfer agent. The message would travel across the internet through various message transfer agents, and the final message transfer agent would keep the email in storage until Jack's user agent requested access to new incoming emails. In this illustration, you can see that the connections between message transfer agents are labeled SMTP. SMTP stands for Simple Mail Transfer Protocol, which is the communications protocol that message transfer agents use to communicate with each other. You might think of SMTP as the language of email servers, kind of like how Internet Protocol is the language of the Internet. Let's examine one more illustration that shows how email systems work. This one shows many of the same things that we just saw in the first illustration, but it highlights some different details. In this illustration, we see a user, Alice, sending a message to another user, Bob. Her message is composed of a short text message that says, "Hi Bob," and then there's a picture of a palm tree. Alice sends this email using her user agent, which relays the message to a message transfer agent. The message transfer agent sends the email across the internet to a second message transfer agent. This second message transfer agent holds the email for Bob until his user agent downloads all of his new incoming emails. Bob can view the email through his user agent. This illustration helps to show us how email addressing works. When Alice addresses this email, she specifies that it should go to bob@dougj.net. Well, where exactly is dougj.net? It turns out that everything following the @ in an email address is the name of a specific message transfer agent somewhere on the internet. So, in a non-technical sense, the email system asks Alice, "Which message transfer agent do you want me to send this email to?" Alice responds, "The one for dougj.net. And then the email system asks, "Okay, now which user at the message transfer agent do you want me to deliver this email to once it gets there?" And Alice responds, "Send it to Bob." The email address tells the computer, "Send this email to the username Bob at the mail server called dougj.net. Now, every email keeps an official record of what it is and where it's been. When Alice first composes the email, all it contains is a message and an address. However, once she hits send, her user agent will attach a header that gives the recipient more information. It will add a return address, which shows the recipient who the email came from. It will also add something called a MIME header. MIME stands for Multipurpose Internet Mail Extension. It turns out that when email protocols were first designed, they were only designed to handle plain text messages. However, MIME allows email systems to work around this limitation. The MIME header allows emails to carry different design elements that go beyond plain text, elements such as images, special fonts, and file attachments. The MIME header on an email will explain what the email contains. In this case, it will say that Alice's email contains text and an image. When the message goes to the first message transfer agent, that message transfer agent leaves a header of its own so that there's a record of where the email has been. All subsequent message transfer agents will leave headers of their own as well. In this illustration, there are only 2 message transfer agents, and so the email only picks up 2 message transfer agent headers. The email arrives at Bob's user agent with all of these headers attached. In many cases, the headers will end up being much longer than the email message itself. To reduce clutter, most modern user agents won't display all of these headers, at least not by default. In Bob's case, he can only see the message and a reduced header that tells him who sent it. However, user agents will allow you to see the full header if you ask for it. You could try this with one of your own emails. To view one of these full headers in your user agent, open an email and look for an option that says something like View Full Header or Display Message Details or something like that. Normally, you wouldn't have much reason to be interested in these headers. That's why most modern user agents hide them. But sometimes they are useful. For example, it is useful that a header keeps a record of where an email has been. Sometimes cybercriminals will send forged emails that pretend to come from a trusted source, say your workplace or your grandma. But if you learn to read email headers, you can check for yourself which message transfer agents the email originated from. Cybercriminals can fake the return address on an email, but they cannot fake the message transfer agent headers. If you receive a suspicious email that claims to be from your grandma, it's possible to check the detailed header of the email to determine whether it really came from the same message transfer agent as your grandma's other emails. Okay, that's all for now about email systems. Of course, there is much more to learn about how email works, but if you followed along with this lecture, then you probably already know more than most casual users do. In the next video, we'll talk about security threats that come through email, and we'll identify some ways to avoid, or at least to minimize, these threats.